Good morning, everyone. So, welcome to my YouTube channel, Avatarm. So, today we are going to discuss fifth problem set on uniform convergence of functions. So, if you have not subscribed my YouTube channel till now, please subscribe it for latest news on mathematics. So, let's start today's session now. Okay. Consider all sequences of continuous function on 0 to infinity. Identify which of the following statements are correct. If f1 converges f pointwise on 0 infinity, then limit 0 to infinity f(x) is equal to 0 to infinity fx. Okay. Second option is if f(n) converging to f uniformly on closed interval 0 to infinity, then this limit is equal to integration 0 to infinity fx. Third option is f(x) converges to f uniformly on 0 to infinity, then f is a continuous function. Okay. Option number D, there does not exist a sequence of functions on 0 infinity such that fn converging to f uniformly on 0 infinity, but limit of integration not equal to integration. Okay. So first you see that first option is not correct. Okay. Why? Because you see that I have given you, we have seen this. I am giving you example. I am recalling that one. We have seen this example. fn(x) is equal to n square x if x in this range, okay, minus n square x plus 2n if x in this range. Okay. And third was it was 0 if okay. We know that this function fn converges to f 0 pointwise on closed interval 0 to 1. But in question it is given that interval is given 0 to infinity. What I will do, I will make it here infinity. It means I am taking 0 in this interval. I will remove 1 and I will put infinity. Okay. What I will do, I will put infinity here. Okay. Then obviously it will converge to 0 function on this interval. Same argument will work because function is 0. And what about this? 0 to infinity fn dx. What is this? This is nothing but 0 to 1 because function is 0. What was that? This limit. What is this limit? We have seen that this limit is 1. And what is the limit of this? This is my f. So what is limit? Because pointwise limit f is 0. That is 0. But they are not converging. This sequence of integral is not converging. But limit n tending to infinity, 0 to infinity, fn dx, that is 1. But it is not equal to 0. It means 0 to infinity f dx. So first option is not correct. And you can see that the sequence of function is continuous. So first option is not correct. Okay. Second option is if fn converging to f uniformly, then limit exists. Second option is also not correct. Why? First option is not correct. Second option For second option, you take this sequence. Fn x is equal to 1 by n. Now you see that Fn converging to 0 function uniformly, because it does not depend on x. But what about integral? What about this integral 0 to infinity Fn dx? That is actually 1 upon will come out 0 to infinity dx. That is infinity. Because any shift, where this limit going? Tell me, where this limit is going? This limit is going to infinity. But what about, because function is 0, but 0 to infinity f dx, what is this? Because function is 0, so this integral is also 0. So it means limit and tending to infinity, 0 to infinity f and dx is not equal to 0 to infinity f dx. Even function converges uniformly, but still it is not correct. So option number B is also eliminated. So option number B is not correct. And we know that third option is Fn converging uniformly on closed interval 0 to infinity. Then uniform limit of continuous function is a continuous function. So obviously you take any domain. So option number C is going to be correct. So this option is correct. Okay. So option number C is correct. And option number D is there does not exist a sequence of functions Fn on closed interval 0 to infinity such that Fn converging to F uniformly, but this limit not equal. Yes, we have found there exist such sequences. Okay, we have just written Fn x is equal to 1 by n. So option number D is not also correct. Okay. Okay, so option number C is correct. Okay. Now move to second question. Fn x is equal to x into e to the power minus x square, x belongs to R is given. Then the sequence Fn is option number A, uniformly convergent on R, does not converge uniformly on compact subset of R. C is bounded, not uniformly convergent on R. D, a sequence of unbounded functions. Okay. Let's see it. So what is Fn x is equal to Fn x is equal to e to the power minus x square. X belongs to R. Okay. First you see its pointwise limit. If I am taking x is equal to 0, then what is this? This is 0. Where it will converge? It will converge to 0. Okay. If I am taking x not equal to 0, then Fn x is equal to, what is this? It is x upon e to the power n x square. Okay. Okay. So when n tending to infinity, this will go to infinity. So this will go to x upon infinity, that is 0. It means f(x) is 0. Okay. So it means Fn converging to 0 function pointwise. My f is 0 function. Okay. Now what is Mn? Mn is supremum of Fn x minus f x belongs to R. What is that? It means supremum will be equal to this. Now I will find supremum, this supremum. Okay. Because a function is uniformly convergent to some f if and only if Mn tends to 0 as n tending to infinity. Okay. So what is supremum? We are going to find supremum. Fn x is equal to x e to the power minus x square. What is that derivative? Fix n. I'm fixing n. Okay. Then what is the derivative? X. X का derivative is 1. X. What is the derivative of this? Minus 2 and x. You take common e to the power minus n x square. 1 minus 2 n square, sorry, n x square. N x square. Okay. To find maxima and minima, because we need supremum error, so we are putting it to 0 so that we can find maximum value, maximum minima. So when it is 0, when derivative is 0, this implies x is equal to plus minus 1 upon under root 2n. Okay. So what is Mn now? What is Mn? Mn is supremum of x belongs to R, Fn x. Okay. But that is supremum of, what is this? X minus x square. Okay. It means supremum x belongs to R e to the power minus x square. Now we have x is equal to plus minus under root 2n. Put that value. Then it will be less than 1 upon under root 2n e to the power minus n 1 upon under root 2n square. So what you will get here? That is 1 upon under root 2n and that is e to the power minus 1 by 2. Okay. So this implies Mn is so it is equal actually. So Mn is equal. It is equal. So Mn is equal to Mn is equal to 1 upon under root 2n e to the power minus. Now you see that when n tending to infinity, it goes to 0. This implies Fn converging to 0 uniformly on R. Okay. So which option is correct? So which option is correct? Let's see. So it converges uniformly on R. Uniformly convergent on R. So option number 1 is correct. Okay. Does not converge uniformly. It is not correct. If it is converging uniformly on R, it will converge to compact subsets. Okay. It is bounded and not uniformly converged. It is bounded, no doubt. Each Fn is bounded. But actually, not convergent is not correct. Okay. So option number C is not correct. D is sequence of unbounded functions. These functions are bounded. Okay. These functions are bounded. So option number D is not correct. Okay. Now move to question number 3. Let Fn, let C naught R be the space of all the continuous function over R such that limit is 0 when extending to plus minus infinity. Let C naught R be cubified with supreme norm of uniform convergence. Let Fn be a sequence in C naught R and F belongs to C naught R. Which of the following statements are correct? Option number 1 is Fn converging to F uniformly on compact set. Then this tends to 0, norm fn minus f. If fn minus f tends to 0, then fn converging to f uniformly on compact sets. Option number C is fn converging uniformly on compact set if and only this norm difference tends to 0. Norm of this difference tends to 0. Option number D, neither of those statements fn converging to f uniformly on compact set and fn norm of this difference tends to 0 implies the other. Okay. Now you see that what is this? What is this? If f belongs to C naught R, what is this norm? The meaning of this is supremum x belongs to R fx. The meaning is this. Okay. Then what is the meaning of this? Fn. If fn and f belongs to C naught R, then what is the meaning of this? The meaning of this is fn x minus f. So fn converging to f in this norm, if and only fn converging to f uniformly. It is true. Okay. A sequence will converge to f in this norm if and only fn converging to f uniformly on this. Okay. So obviously option number B is correct, because if fn and fn minus f norm tends to 0, it means fn converging to uniformly. So obviously when fn converging to f uniformly on R, obviously smaller domain, the compact subsets of R, it will converge. So option number D is correct, because fn minus f difference is tending to 0. It means fn converging to f in this norm. It means fn converging to f uniformly on R. So obviously in compact subsets it will converge. Okay. So option number B is correct. Okay. Option number B is correct. So why option number A is not correct? Because we know this. We can define a sequence. Okay. You see this example. I am taking this sequence 1 minus mod x upon factorial 1 plus mod x square upon factorial 1 minus mod x cube upon factorial 3 plus minus 1 to the power n absolute mod x to the power n. Okay. We are taking this if our x is less than factorial n plus 1 and 0 otherwise. Now you see that fn converging to f e to the power minus mod x pointwise. But we know that such sequence we have seen in e to the power minus x, 1 minus x upon factorial 1 plus x square upon factorial 1. This sequence converges on closed interval 0 to infinity to e to the power minus x pointwise, but do not converge uniformly. Okay. And it converges compact subsets also. Okay. Same idea we have used here, and we have taken power minus mod x so that we can extend it on negative real line. Okay. So now you see that fn converging pointwise on R. Okay. And fn converges to f uniformly on compact subsets of R. But fn do not converge to f uniformly on R. So we have this example. fn converges to f uniformly on compact subset, and it converges pointwise to e to the power minus x pointwise on R, but it does not converge to uniformly on R. Okay. So option number, and this function e to the power minus mod x satisfy this condition. To take limit, this limit is tend to 0. So e to the power minus mod x belongs to C naught R, each Fn is also belonging to each Fn belonging to C naught R also. So all the conditions are satisfied, but it converges compact on compact set, but it does not converge on R uniformly. So it means option number D. So option number A is not correct. So option number C, if Fn converging uniformly on compact set, if and only if this happens, it is not correct. Because if one direction is not correct, how if and only if correct, statement can correct? Because A is not correct, so C cannot be correct. And neither of two statements implies the other. It is not correct, because if uniformly Fn minus F tends to 0, it will converge uniformly on compact set. But converge is not true. So neither is, no statement is true is not correct, because one statement is correct, one direction is correct. Because Fn converges to F uniformly, then Fn converges to F uniformly on compact set. Okay. So option number D is also not correct. That is why option number B is correct. Okay. Now see this question. Let C naught R be F R to R. F is continuous on R. Okay. Continuous on R. 1 minute. Let me check. We have to make this Fn continuous. Okay. There is some problem. Okay. Now you take one thing. What I will do? What I will do here? I am to define this. I will do one thing. I will do one thing. You take this. So what you will do after factorial, and suppose what I will do. So suppose Fn's are on factorial minus factorial n plus 1, factorial n plus 1. What I will do? The Fn's are not contained here, but we will define as such a way that they become contained. So somewhere it will be at some stage here. What I will do on factorial n plus 2, factorial n plus 2, I will join it by a straight line. Okay. And rest I will take 0. Okay. So a straight line, it is a straight line joining base to point. A straight line. There is some point. I am taking this straight line. Okay. Okay. Straight line goes to a straight line. Okay. Straight lines. Okay. And it is 0 if your mode is factorial n plus 2. Okay. Now this function is continuous. Okay. This side you take this straight line, and this side you take this straight. I am not mentioning the straight line, but this idea will be used. Okay. Now see that this function is continuous, and this belongs to C naught R, and this converges pointwise on R. Okay. Okay. So pointwise, but this is not uniformly converging to R. So this idea will use here. I do not see that this function is not going to be continuous. It happens. So I made it continuous by this way. This way. Okay. Now we see this function question. Let CCR F R to R, f is continuous on R, and fx is equal to 0 for all x belongs to k to the complement of k. Okay. It means CCR is a collection of all the continuous function from R to R, and fx is equal to 0. It is outside the compact set. Okay. And gx is equal to e to the power minus x square for all x belongs to R. Which of the following statements are true? There exists a sequence Fn in CCR such that Fn converges to G uniformly. Second is B. There does not exist a sequence Fn in CCR such that Fn converges pointwise. C. If a sequence in CCR converging pointwise to 0, then it must converge to 0. Okay. There does not exist any sequence in CCR converging uniformly to G. Okay. First of all, I will say that CCR is dense in C naught R. It means you take any sequence in C naught R, there exists a sequence Fn which converges to F uniformly. Okay. What does it mean? It means that, what is the meaning of this statement? What is the meaning of this statement? It is dense in C naught R. It means that if you take C naught R, there exists Fn sequence in CCR such that Fn converging to F uniformly on R. Okay. So whether any such kind of option is matching, there exists a sequence in CCR such that Fn converges to G uniformly. You see that Gx belong to, what is the limit of Gx function? Limit of Gx function is 0. This implies Gx is equal to e to the power minus x square belongs to C naught R. By this argument, there will be exist a function in CCR such that it will converge to e to the power minus x square function uniformly. So option number A is correct. Okay. Option number A is correct. There does not exist a sequence Fn in CCR such that pointwise. It is not correct. Why? You see that in previous question, we have defined such sequences. Fn 1 minus mod x upon factorial 1. Here what we will do? We will define this kind of sequences. 1 minus mod x square upon factorial 2 plus mod x to the power 4 factorial factorial 1 minus mod x square 4 factorial, sorry, here will be factorial 1. Factorial 6 2n upon factorial n. Okay, if mod x, where we will take here, we will factorial n plus 1 square will be take. Okay, like that. Okay, and we will take straight lines as mentioned earlier. Okay. In this factorial n plus 1 minus factorial n plus, there will be fn. What we will do? We will take a straight line here, minus factorial n plus 2 factorial n plus 2 square. Okay, up to square. Okay, and rest part we will keep 0. Okay. If now you see that each Fn belongs to CCR, because after compact outside a compact set it is 0. Compact set, what is compact? Minus factorial 1 plus square to factorial n plus, sorry, minus factorial n plus 2 square to factorial n plus 2 square. Outside that complement it is 0, but that set is compact. It means Fn is 0 outside that compact set. So each Fn belongs to CCR, okay, and Fn converges to e to the power minus x square pointwise. But Fn do not converge this uniformly. But it converges pointwise, na? So our option B is not correct. Because here it is given only pointwise. If a sequence in CCR converges pointwise to G, then it must converge uniformly to G. It is not correct. I have given example where pointwise it is converging, but not uniformly. So option number C is not correct. Okay. Does not exist any sequence in CCR converging uniformly. It is not correct. It is a theorem. If you take any G belong to C not R, there will be a sequence in CCR that will converge to G uniformly. So it is not correct. So option number A is correct. Here, when I define this sequence, you can skip the mode because x square is equal to mod x square. You can also write here, if you want to write, simply skip the mode here. No problem. Okay. So I'm writing. Okay. Because x square is equal to mod x square. X to the power is equal to mod x to the power 4. Okay. But here you have to write. Okay. Now we are moving to fifth question. That is last question. Fnx is equal to 2x upon pi tan inverse nx be defined on R. Then Fn and Fn dash are uniformly convergent. Okay. Fn is uniformly convergent on R, but Fn dash is pointwise convergent on R. Fn is not uniformly convergent on R. Fn dash is not uniformly convergent on R. Okay. Now see this. Fnx is equal to 2x upon pi tan inverse nx. Okay. So what is, if I am taking x is equal to 0, then Fnx is equal to 2x upon pi tan inverse 0. Okay. I am putting here in place of x, we are putting 0, so it is actually 0. Where it will converge? F0 is equal to, it will converge to 0. It will converge to 0. Okay. So, if we are taking Fnx is equal to 2x upon pi tan inverse nx, then where it will converge? It will converge to 2x upon pi tan inverse infinity. What is that value? Pi by 2. Okay, so it will be cancelled out. It will be x. It means that is my fx. It means Fn converging to x, fx. Okay. Now, if I am taking negative, if x less than, okay, then what is fn x? 2x upon pi tan inverse nx. Because x is negative, it will change to 2x upon pi tan inverse minus infinity. So what is this? 2x upon pi minus pi by 2. That is minus 1. It is minus x, fx. Okay. It means fn converging to x minus x fx. So how we can write it? This implies fx is actually mod x function. Because if we are taking x is equal to 0, it will give you 0. When we are taking positive, it will give you mod x. It means that is positive. If we are taking negative value, it is giving minus x. So it is mod x function. Okay. So fx is equal to, let's write it properly. It will be more clear. So what we have? We have fx is equal to, it is 0 if x is 0. It is x if your x is positive. And it is minus x if x is negative. So what is meaning of this? What is this function? How this function is? We know mod x function is defined in this way. So it means fx is equal to x is a mod x on R. Okay. On R. Okay. Okay. On R. Now you see that what is my fx? Fn x is equal to 2x upon pi tan inverse nx. Okay. Tan x. Okay. Okay. So now fx is given. Okay. Fx is given this. So one thing. There option number 1 is given. Fn and Fn dash are uniformly convergent on R. Okay. Fn is uniformly convergent, but Fn dash is not uniformly convergent. Okay. And Fn dash mod x, it is Fn dash is pointwise convergent on R. Fn is not uniformly convergent on R. Fn is uniformly convergent on R. Okay. So now you see that what happens. Now we are seeing that Fn x is equal to minus fx, that is 2x upon pi tan inverse nx minus mod x. Okay. Okay. So nx, x is here. Okay. So now what I will do here, I will simply what I will do here, which result I can apply here? What is tan inverse nx formula? What is tan x formula? Tan x formula is okay. Tan x formula is x minus x cube upon 3 plus x to the 5 upon 5 like that. But that will not work here. Okay. Okay. So what I will do here, tan x is equal to, actually there is a standard result. Each f and x is monotonically. So I would like to change the question little bit. Maybe it is typo here. Okay. Typo here. I think there is a typo. There is typo. It is not R actually. It's a typo. It is -1 to 1. It is -1 to 1. Okay. And it is -1 to 1. There is -1 to 1. Okay. -1 to 1. Okay. Now, what I will do, you see that it was typo in that question. Now, see that each function is, this function is continuous. Okay. This function is also continuous. This function is also continuous. Okay. Now, for fixed x belongs to minus x belongs to -1 to 1. The function f and x is monotonically increasing. Okay. Monotonically increasing because x is positive, x is 0. It is a constant function 0. Constant function is monotonically. If x is positive, tan x is what is tan x? Tan x is increasing function, so it is increasing function. When you start taking negative x in -1, then x is minus. When you increase n, the minus magnitude will increase, but after producting, it will increase positively. Okay. So it means it is an increasing function. Now, fn is increasing function. Fn is continuous. Each fn is continuous, and f is also continuous. So by Dini's theorem, fn converging to f uniformly on -1 to 1. Okay. Now, what about derivative? What is the derivative of f and x? We know Fn converging to X uniformly. What is the derivative? 2x upon pi tan inverse. What is the derivative? Fn dash X 2 upon, what is the derivative of 1? So tan inverse X. Okay. And what is the derivative of, now keep 2x upon pi as it is. What is the derivative of this? 1 upon 1 plus n x square. Now differentiation of nx will come, that is n. Okay. Because we are taking differentiation by fixing n. Okay. N is fixed. Okay. So here I am doing this problem. So what is Fn? So when n tending to infinity, so nx is this. Okay. 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 X upon nx. So nx. What is the differentiation of tan in 1 upon 1 plus nx square, and its differentiation is n, so it is nx. Okay. Now you see that we know that this function is uniformly convergent, as we have seen already. This is uniformly convergent. But we know that this function nx upon 1 plus n square x square is not uniformly convergent. Not uniformly convergent. We have one function is uniformly convergent because we can take it here. So it will be in this form. Constant will not matter. This function is uniformly convergent, but this is not uniformly convergent. So resultant Fn will not be uniformly convergent. Is not uniformly convergent. Okay. So Fn's are uniformly convergent, but derivatives are not. Derivative sequence is not uniformly convergent. So which option is correct? Option number Fn and Fn are uniformly convergent on R. First option is correct. Okay. Fn is uniformly convergent, but Fn dash, sorry, first option is not correct actually. Because Fn dash are not uniformly convergent. Okay, first option is not correct. Second option, Fn is uniformly convergent on -1 to 1, but Fn derivative is pointwise convergent. Okay, it is pointwise convergent. If you say nx upon 1 plus n square x square sequence converges pointwise to 0 function. So it is a pointwise convergent. So option this is correct. Fn is not uniformly convergent. This is not correct. Fn dash R is uniformly convergent. This is not correct. Because this sequence, this will converge to mod x function. This will converge to mod x function, and this will converge to 0. So this is converging to mod x function. Okay, no doubt, pointwise. But it is not uniformly convergent. Fn derivative is not uniformly convergent. Okay, so here what you will do? X is, you correct it here because we have changed the questions. Okay. If x is belongs to -1, so x is greater than 0. X belongs to -1 to 1, such that x is less than 0. So it is mod function of closed interval -1 to 1. Okay. So we have done this question also. Only I was correct. So today we discuss 5 questions. Okay. So if you have any problem related to this problem set, you can comment me on my YouTube channel. So like, comment, share and subscribe my YouTube channel. And if you have any issue, you can comment also. So thank you very much for today's session. Thank you very much. We will see you in next session. Okay. Thank you very much.